let's start with the UV part. And for the UV, the intention is basically to create the UV on some other geometry and then transfer it on the petals. So let's take the main line where we generated the spine and the resample and copy it. And where we generate the branch here, let's output a null before going into the copy to points. Let's call it out branch. And with an object merge, let's take this null. So now here we have the single branch, the single line of the branch, and the spine line. But for this time, we don't want to be on the z-axis, we want to be on the y. So 0, 1, 0. Leave the length at 6 and also the points, because we are resampling, and here we have the 24 segment that we also have on the flower. Now let's take a copy to points, plug the branch on the left, the resample on the right. Basically, we are recreating a single petal for UV. Now we want to, let me just rearrange things a little bit here. And we want to copy all this part where we are doing the skinning with the split. So basically, we should end up with the same skinning method. And the reason we are doing this is because like this, we have the exact same point order. So we can correctly transfer the UV from here to the full flower. Now let's take a UV texture node after the merge, and let's move in UV space so we can see what's happening. And we need to set it on the Z axis and scale it, let's say 0.2. So we have something like this. So basically the idea is that I want to have a few of these UV island on my UV space. So when I transfer to the full flower, which has 72 petals, each petal will pick randomly one of these island. Right now we have just one petal. So let's take an add node so we can copy it more times. And I want, let's say, 10 variants for the petals. So let's take another copy to points, plug it as usual, and now we should have 10 of these. We also want to store the point number as an variant attribute. So after the add, let's call it set variant, and here let's just type e at many keyboards, e at variant is equal to at picking up. So now we are carrying also this attribute that we need for the variation. And before the actual UV calculation, also let's take attribute promote, because we are going to use a wrangle on vertices, and we need this variant attribute to be on vertices. So from point to vertices, the variant one. And we should have it here on the vertices. Yes, we do. So take a vertex wrangle, and let's move in the UV viewport. As you can see, we have all the copies overlapped with each other for now. Let's call this calc UV. And the way we want to manipulate the UV is just by adding something to the current UV attributes. So at the end, we will have something like at UV plus or equal some new value that we will call, let's say, offset. We will get an error right away, of course, but let's initialize it just at 0. So vector offset set 0, 0, 0. And as you can see, if we type something like 0.2 on the X, the UV will start to move. So this is the idea behind all of this. Now we are scattering 10 of these. So basically we need a grid made of 2 rows and 5 columns of this UV island. So basically we already know that this scale will be too big. Basically we need to half the sides. So let's go back to the wrangle. And for now, let's just comment this out so we don't get the error. And before the offset, we want to do at UV divided or equal 2.0. So right away, we will have the new scale working. Sorry, got an error here. Basically, we need 5 of this here and 5 of this on this other side. So we need to calculate an x and a y coordinate for this island. That will replace it here. So instead of 0, 0, let's do x and y for now. Up here, let's retrieve the variant attribute and let's call it b for simplicity. So e at variant. And for the x and the y for now, let's just set it as 0. So x is equal to 0 and also y, just to get rid of the errors on the code. Now, for the x coordinate, basically all we need to do is take the variant, meaning the v variable, and do a modulus operation with 5, which is the number of column that we need. So v modulus of 5. And as you can see, they are already offsetting. This scale is because we also need to divide the x here over 5. So x divided 5.0. For the y, we just need to do b divided by 5. And this will end up with the same behavior as the x. So also here divided by the number of row in this case, so 2.0. And as you can see now, we have all the island on a full layout. I just don't like that this starts at 0 and I have this gap on this other side. So after the offset, I will do offset plus or equal chp offset. So I'm basically creating another controller to offset this whole thing. So let's say 0.05. And this is the correct UV layout we want. Now, before transferring this UV on the full flower, let's first promote the UV attribute to points. It will be easier for the transfer. So UV from vertex to points. And for the full flower, let's prepare it for the transfer. So let's do a little bit of a cleanup with a group delete so we can get rid of a few stuff. And an attribute delete also. So from here, let's just keep the animation attribute and the petal one. So we have a much cleaner situation. And also here, we need to calculate some variant value. So take a point wrangle. This will be calc variant. And in here, we want to generate some random value based on the petal attribute that we have. So let me go back in perspective view. E at variant, let's set it as 0 just so we can enable the visualizer to check it. And let's retrieve the petal value. So let's call it seed. It will be an integer value and e at petal. So now technically we should have it also here. Yes, we transfer it correctly, but we don't want to use it just like this. We want a random number based on this petal value. And we also want to remap it because right now it will output from 0 to 1. We have 10 variants, so we need to remap it from 0 to 10. So fit 0, 1 over the random from 0 to 10. And this will include the 10 right now. So we are actually out of one value, but we want to also cast it as an integer. So this will truncate the last value and we are good to go. So we should have a variant attribute going from 0 to 9 also here. And now we want to take a point wrangle to do the actual UV transfer. So the full flower input 0 and the UV petal input 1. This will be UV transfer. So here, basically, at the end, we will have the UV attribute that will be equal to some UV value that we're going to use to transfer. So this will be a vector attribute, just like on the other wrangle. So vector UV value we are going to retrieve this from the other input, from the point, from the corresponding point coming from the other geometry. So we're going to use the point function. From the geometry one, we want to take the UV attribute on the correct point. Let's call it match PT. So basically all we need is this point number and we need it correct. So to calculate the point number, we need some information. First, we need the amount of point on each petal that we can see up here is 250. And we need also this point number like before resetting for each petal. So with the modulus operation. And finally, we need the variant value that we have. So for the point count, let's call it petal size. It will be equal to 250. And the, let's call it local point number. So local pt, it will be equal to at ptnum modulus of petal size. Finally, the variant, we just want to retrieve it from the attribute. So e at variant. And now the match pt that we need to calculate, basically we want to take the variant. So variant multiplied for the petal size, and plus the local pt number, local pt. Why do I get an error? Oh, I don't need the parentheses. So as you can see, something is happening. We are viewing the petal geometry, so it seems it's working. And this is actually surprising because I was expecting, like in my original scene, I had some mirroring effect on the petals, so I was expecting this to sort of work, but like in my original scene, I had to do also a resorting of the points after the skinning by setting by attribute and using the original petal one. So I'm curious to see if there is any difference here. And there is a difference, but apparently for some reason, while I'm recording this, basically it would work also without the sort. I will leave it as it is, so if you need it, feel free to use it. I don't know, maybe I'll figure it out why in my, like, if I need to show you without the sort here, I have a real mirroring effect. I mean, this wasn't good for me. So with the sort, I fixed the issue. And for some reason, we don't have it here. So whatever. Now, after the transfer, we are basically done. So we can finally fuse the points and get rid of that seam on the mesh. So now let's hide some stuff. You can see we don't have the seam anymore. And after the fuse, let's also take a rest that we want to use for the noise. Otherwise, the noise will be sort of animated in a flickering way. We don't want it. So the fuse will go on the left side. And to compute the rest, we take a time shift. This will be on the last frame. So delete the channels here. And we will take the rest coming from the time shift. So now we want to add a little bit of noise to break up the shapes. So take a point bot. We will do it with a couple of noise like we did many times. So dive inside the VOP and we want to add something to the current position. We don't want to use the position to drive noise. We want to use the rest we just calculated. So take a bind node. We take the rest, which is a 3 float. Now let's drop down a couple of turbulent noise and use the rest to drive the position. This will be both 3D noises and where is it? 3D noises, and we want to add both of them to the current position. So 1, 2, and this will go into the position. So for the parameter, let's set the first one as a spark convolution and let's promote the frequency, not the offset, but the amplitude, the roughness, and also the attenuation, so we can control it from outside. On the second one, let's set it as original Perlin and promote the same parameter. We don't want to promote the offset because we want to use the petal number to generate some random value and differentiate the noise on the petals. So let's take another bind. This time we want to take the petal attribute, which is an integer one, and we want to use this to generate some random value. So take a random node, take to multiply constant, so we can offset this value by a lot. So let's set the first one to some high random value and also the second one. Then take a set vector component, which is right here, and we want to use it to set just the y-axis on both of the noises. So take another one, plug the correct value, and this will be fed into the noises. So 1 and 2. Now this is way too strong, so go outside and tweak the parameters a little bit. Let's set one noise to 0 for now, so we can tell the two noises apart. And let's see, for the first one, I want, maybe this will be the low frequency one, so something like this is already good. And for the other one, we will use this as the high frequency. So increase the frequency until we have something like this and lower the intensity. Of course, this is way too much. So also the roughness, maybe 0.02, very, very low, just to break up the shapes a little bit. And we do have something weird here. Is this you? No. Is this you? Yes. I believe that this also is way too strong, so let's lower it to something like 0.004. Just very subtle deformation. Why is the rest complaining? Topologies don't match is not a valid source. Okay, something is not right with this point count. It should be another number, so let's investigate this. This is fine. There's something wrong on the... Oh, I don't want 93 petals. They should be 72. Let's see. Yeah, the point count now seems correct, and we should have the error anymore. Let me check, because now I'm curious if this was the reason it wasn't working. Yeah, now I have the mirror effect again. Amazing. Okay, the sort was needed after all. So we did the noise. Let's just prepare the final stuff. And you may have noticed that after the fuse operation, we get this point up here. I mean, we don't have the perfect straight island, but this won't be a problem. But just one thing, maybe I want to smooth this value a little bit. So if you check the inside, it could be a good thing to smooth the inner topology of the UV island. So with an UV smooth node, let's set it, or rather, let's leave it as it is. It's already doing enough. And after that, let's promote the UV back on vertices for texturing and rendering, because right now we have it at point level. So UV from point to vertex. And let's take an attribute delete so we can clean everything we don't need anymore. So right now we finished with all the attribute for animation, so delete non-selected and just take the petal, because it might be, I actually use it for shading, so it can be useful. And of course we don't want to delete the UV. That was much of an effort, so keep it. And I believe that's it. Maybe a subdivide, so we can get higher subdivision level. and finally a normal node. Let's also take a null, and this will be out main flower. And basically we finished the main flowers. For the inner part is basically a simplified version of this procedure, so maybe I'll try to go more quicker because this is getting really long as a tutorial. But let's go at the top and let's copy all of this for now, the main copy to points with the fillet axis. This time we won't use a fillet axis, we will just use a circle. But first, let's change this line to be on the y-axis and decrease the length to something like this. We need a shorter one. Also, for the normal and up vector, this time the normal will be on the z and the up will be on the y. So like this. Then delete the wrangle for the file taxi and drop down a simple circle. Set the circle to the z-x plane and 0.37 on something like this for the scale, and increase the subdivision all the way up so we have a smooth circle. Then drop down a poly extrude node. We want some thickness to it because otherwise the points will all be scattered on the circumference. And let's just increase the inset a little bit, something like this. And we don't want the from group, so we can use a scatter node here. And let's say that we want to scatter 82 inner, I don't know if they are called petals, I don't think so, but the inner stuff of the flower. So this will be on the init attribute, and we already have the scatter. Now let's go on the init attribute node. There's too much stuff here, we don't need all of this. Let's delete everything here about the p scale. We will calculate this later, and also this normal y stuff. So delete also the b box. So basically we have the duration, the float anim. We will move this up here so it's much tidier. And of course we have the error on this normal y. We don't have it anymore because we want to calculate it in a different way, and also rename it something like distance, because it won't be based on the y, rather on the distance from the center. So let's make some room, and here let's create this distance variable. So we want to take the length of the position. So length at p, and let's just display to see the attribute. Right now, there's not much of a difference because this is not normalizer, neither fitted. In some way, we want to fit it. So fit this length, and we will fit it between two float channels. So one will be min dist, and one will be max dist. So we can control it better, and it will be fitted between 1 and 0. So now if we create this pair parameter, and let's delete the ramp because it's not here anymore. Also the p scale, so delete spare parameter, also this. So basically we should start to see some value. So something like this. As you can see, we have the control of the range. So now if we play it, we should have the correct animation, and we don't have it. Why? Duration is set to 100. Because we are seeing the this, not the anim value. Okay, this is correct. Now let's drop down another point wrangle. We will use this just for the p scale. So calc p scale. And in here, let's visualize the copy 2 points. and let's say f at p scale is equal to p scale, and for the p scale value, flow at p scale, let's set it to 1 just so we don't get error, semicolon. And we want to use a ramp. So chramp scale based on the distance attribute we just created. So f at dist. Let's create this pair parameter, and we want let's set it to b-spline, and we want something like, I don't know, something like this maybe. I'm not sure it's not working. No, why? Oh, because it's not those, it's this. Okay, now it's working. And I also want to animate this based on the animation value. So when we are at the end of the animation, this will be longer. So here, also multiply the p scale value by the f at anim, but we don't want it to we don't want to use the full range from 0 to 1, otherwise this will shorten the lines too much. So hit 0 1, because we know that the animation value is going from 0 to 1, and let's fit it from 0.2 to 1. So now we should also have some growing effect like this. Now for the rotation, I actually want to split the layout here, so I can check from this other angle, the rotate spine one, because it will be similar. I don't want to duplicate it because then I will have to delete all the ramps that I don't need. So let's pin this to the number 2, this to the number 1. And here, let's take another rig attribute to wrangle. This will be rotate inner, I don't know. And let's see what we want to take from this one. I'm sure we want the animation value, so copy that right away, and also the dist ramp, because we also have the dist attribute we calculated before. And for the various ramp, I will say that since the flower is closed at the start of the animation, there's no need to have two separate ramp, two separated ramp from the near and the far portion. But at the end, I want a major difference from the outer line and the inner one. So I will take the start angle for the start ramp, and only the start U, like this. Of course, this would get me an error, so the actual start U can be like this, should be something like this. So let's copy this and replace it with the merge. And we didn't bind the U, so plot U is equal to f at U. And instead, for the end ramp, I want the angle, but I want this whole block because I want the two separated ramps. So paste all of that and get rid of this run angle. This is not needed anymore. This is correct, yeah. And let's change this name to start U, otherwise it will be confusing. And for the rotation, let's move back there, compute the final angle for the matrix rotation. It will be distance multiplied the lerp, I never write it correctly, from the start U to the end U using the animation value. Create the matrix, X-form. We will start from the identity one as usual, and then we will rotate it in radians by the angle using the cross vector. And yeah, we don't have the cross vector yet, so let's compute it before the angle. So vector cross, it will be equal to the cross function between the normal and the up vector. We did have the up vector here. We did, yeah. So comma be at up. And finally, apply the transformation. So for local transform is equal to xform by 4 at local transform. And hopefully everything should already be working. Let's increase the angle to some high value, like 120. And let's see. No, it doesn't seem it's working, but we need to fix the ramp. So let's see. This ramp should be like this. So, but it's not working. Let's set the U ramp in neutral position, so 0.5 for now. And so we can debug the whole thing. So this is the start. And if I increase the start U, there's something wrong. Let me try, don't use the up vector, let's just try to, okay, apparently we didn't have the up vector on the right stream of the geometry. And obviously I forgot to create the normal on the scatter points, because as you can see, we have none. So here after the p scale, just very quickly at and normalize at p. And now we should have the correct behavior like this. So now it's just a matter of tweaking the ramps and the angle as we want. So for the start, I want something like this. And not that it matter that much, because it will be all covered by the outer petals, but anyway. And for the end, this is the end near, set it to be spline. Let's move also to the end of the animation, and let's see, something like this for the near. And for the far, I want and I don't like the actual interpolation between the far and the near, but I don't want to change this ramp. Otherwise, this will change also the behavior of the outer lerping, because the distance is used here. Okay, I don't like the way it's used here. So basically, I want to create another ramp to separate the control of just this inner interpolation between the inner and the outer one. So instead of just the raw distance variable, we want to lerp with another ch ramp. Unfortunately, we will call this and this ramp, and it will be based on the raw distance attribute. So, and we can close this so we can have more space. I close, oh, okay. So basically, if we create the other space parameter and is the final ramp, we can sort of clamp the interpolation between the outer and the inner values. All right, did a little bit of tweaking. Basically, in the end, this ramp, I want to be something like this. So this kind of interpolation. And for the end, near and far, I did something like this. So feel free to use the exact same value or change it. And for the angle, I'm using 120 on both of them. So there's no really need to use two separate angle. So let's do like this and use the start angle also for the other one. So we can get rid of this end angle. So we have something like this for the inner part of the animation. Now, after this rotate inner, let's take another orientation along curve. We will need this for the sweeping part, otherwise the mesh will be all messed up. And in here, we want the target up vector as y-axis, the activate up and n, and we want to use the transform matrix for the meshing part. Now let's take a sample. Just like before, we want to have a consistent number of points. So let's set it to 24 just as the other one. So now we want to take a sweep node from the resample and is complaining because we don't want a second input cross section. We want a round tube, something like this. And let's see, set the radius to something lower, something like 0.6, and we also want to scale along the U of the curve. Oh, and also we need the U here, so U. And so apply along curve, and let's do something like this. So we have this kind of shape. Of course, you can tweak yours as you want. And I don't want to compute the UV on this sweep node because this is animated. So I want to take a time shift, set it to the last frame, so 250. And this will go in another sweep. So this is basically static. And on this one, we want to compute the UV attribute. So enable compute UV. And let's visualize it. Let's see on this scale, disable this one, and we should be fine, sort of. Let's also take a UV layout, and let's see what we have. Let's disable the axis alignment. They seems way too small. I don't know why. Oh no, they're fine. Okay. So now we can transfer those back to the animated version and have some consistent UV. So take again a vertex triangle. This will be much simpler than the main flower one because here we just need to transfer directly the UV attribute from the vertices of the second input. So V at UV is equal, we use the vertex function to get from the geometry 1 the UV attribute from the current vertex pair, so VTX num. And is complaining why we miss and comma. So now we have the correct UV on the inner part. Let's take an attribute delete so we can do some cleanup. And just take the UV attribute from the vertices. We don't need anything else. So take a null. This will be out inner. And let's maybe do some cleanup. And now take two object merge, one for the inner part and one for the main flower. So we can merge those two together and see how they look. And it's working, but I want to delay the animation of the inner part, so I will take another time shift, this time on the animated version of the sweep, and I will just subtract some value like 80 frame from the time shift. So basically we are delaying the whole thing, and the inner part it will start to open 80 frame later compared to the middle part. And I know there's a lot of compenetration right now, but at least from my angle of camera, those weren't a problem. And that's basically it for this tutorial. That I will actually, I believe I'll split it in 2 or 3 parts. I will see about that. But we did everything about the flowers that I wanted to show you. The only thing I have more in my original scene is the background, but it's something that quite simple and we covered other times during my videos. So, as usual, I hope you found this content useful, and if you did, drop a like and subscribe to the channel, and see you in the next one. Cheers!